We'll implement that later. If you work in software, you've heard that sentence. So I ran an experiment. I asked AI to build an app, step by step, using vague prompts, the kind we give early in real projects. At the end of every prompt, I asked the agent to write down every assumption it made, every ambiguity it noticed, and how it resolved them. The result was a series of snapshots of an app that's slowly being iterated on, alongside the agent's assumptions and process. It was actually fascinating, and we really should talk about this. The setup was pretty simple. I asked two AI agents to build the same small application step by step through 12 prompts. The prompts were intentionally vague and general. Things like add a user profile, allow adding a user, let users choose how they want to be referred to in the interface. Real early stage project instructions, but every step had one extra requirement. The agent had to explain what assumptions it made, what ambiguities it saw, and how it decided to resolve them. Then I committed every step to Git with a Git tag and build a viewer app around it. So you can literally replay the evolution of the application and read the agent's summary, assumptions, and decisions, which means you can watch how these assumptions slowly turn into the architecture. There's actually a lot more into this than I expected, and I encourage you to play around with this. The link is in the description, but here are some high-level insights. I asked in an early prompt to add a preference for how users should be referred to. Very vague. I actually didn't realize how vague it was, which is a point on its own. One agent interpreted it as adding pronouns. The other agent interpreted it as adding a display name. That difference didn't really matter at first, but it did later when I introduced translations to Spanish and French, two languages that have gendered verbs and nouns. The agent that earlier modeled pronouns anticipated that gendered languages will have more challenges. So it adopted a stronger internationalization setup, anticipating complexity. The other agent treated the initial translation request as a relatively simple string replacement and decided to build a lightweight custom translation system. But more than that, it never revisited that decision. Even after prompt, where I added more and more complexity to the internationalization system, it kept thinking that each one of those changes is small enough to just add to the bespoke system, not quite realizing or thinking that at some point maybe it's worth going with a pre-baked, already made, bigger system. Now, none of this was strictly wrong, but the early decision created architectural gravity. It influenced the assumptions and decisions in later iterations, and arguably made it easier to fall into a bit of a sunk cost fallacy problem. The other agent ended up making slightly fewer compromises because it worked with a more robust system that allowed for covering more of the edge cases it encountered. When I asked the agents to create a form to add users to the system, both agents decided that they will generate the username instead of asking for one. One agent generated it from the given name and the other from the given display name. Seems fairly reasonable. Now, both agents immediately anticipated having to handle name collisions, and both anticipating having to handle non-ASCII characters inside a name, even before translations were added. One agent decided to just strip non-Latin characters from the name and use whatever is left to create a username. The other agent decided that if it cannot immediately create a username from the given name, it will just create a fallback one, user and a number. Now, look at the assumptions here. Both users assume that a normal user is one with a completely or mostly Latin letters. All other cases are edge cases that require fallbacks, or none. The fascinating thing here is that neither one of the agents revisited this operation of username creation in later prompts, even after I asked to add languages with clearly non-ASCII characters like Arabic and Farsi and Hebrew. As a result, when I tried to add a username in Hebrew to the final app, one app produced an empty username, and the other app just gave me a generic numbered username. The original assumption that most users have mostly Latin-based names stayed baked into the architecture. So localization didn't exist at the beginning of the experiment on purpose. I added it later, the way many real products do. So eventually, when I introduced right-to-left languages like Arabic, Farsi, and Hebrew, both systems implemented support. Technically, mostly correctly. The interface flipped right to left. Directionality tags were mostly correctly added. The inputs were expecting right to left content. It was correct in technical terms, mostly following best practices. In fact, Some of the implementation was better than many other websites out there. But then I actually loaded the page as a user would, and it wasn't that great. All the user-generated content, comments, post content, which the agents both knew about, didn't isolate properly, so visually it was broken. This is the difference between implementing a feature and actually modeling how humans use it. It is also, unfortunately, quite common for right-to-left language support. The fascinating thing is that AI didn't invent these problems. It reproduced patterns that already exist in our industry. Generative AI is trained on how we build software. Watching it build an application is like watching our own development instincts, just faster and narrated. And because the agent explained its reasoning at every step, we can actually trace how assumptions accumulate. It's basically a time lapse of architectural decisions as they form. And look, assumptions are unavoidable in software development. Humans make them, AI makes them. The real question is whether those assumptions stay invisible. Because invisible assumptions become constraints, but visible assumptions become decisions. And decisions can be reasoned and revisited. That's the real lesson from this experiment. It's not about AI, it's about making assumptions visible. There's a great video from Pseudo-ish about this concept as it relates to code review and how important it is to explain assumptions when working with pull requests. It's worth a watch. You'll find the link in the description. So if you want to explore the experiment yourself, you can actually replay every step of the build and read all of the agent's notes, assumptions and all. Links are in the description below, including a blog post I wrote about this. If you find anything interesting, please share it in the comments. And I'm planning to talk more about this and delve deeper, especially around assumptions regarding localization, identity, and translation, because some of the most interesting insights happen in the tiny decisions we normally ignore. So stay with me, join the conversation, and stick around. I assume I'll see you in the next video.